Okay, here we go. This is review A. Before we get on to review A, let's go over all of the major formulas that we have here in Unit 10. So here's a good list of the Unit 10 formulas. Okay, so we begin off with the comparison and the hypothesis testing with Unit 10. And so some simple ones are we come up with a difference, which is x1 minus x2. We have to have the average of those differences, which again is the sum of the differences divided by the number of numbers. Okay, easy peasy. That leads us to our standard deviation that we have here. And the standard deviation in this situation is the sum of d minus d bar squared divided by n minus 1 square rooted. That gives you your square or your standard deviation. And then we have a t, which is d bar divided by s divided by the root of n. Okay, those formulas right there get you through the hypothesis testing of a difference. Okay, and then we venture kind of into the realm of, I'll just kind of post it over here for right now, of the the confidence intervals dealing with those sort of ideas right there. So again, confidence intervals. Okay, both of these are going to run off the same kind of confidence interval itself, which is x bar 1 minus x bar 2 minus e is less than mu1 minus mu2 is less than x bar 1 minus x bar 2 plus e. All right, so both of them are going to use that exact same confidence interval. The e, on the other hand, the margin of error, is the difference between these two different problems. All right, so there's one in which we have a sigma. That's z. C is going to be equal to sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. That bit is square rooted. Okay, and then the one where you have s's is going to be a tc of s1 squared divided by n1 plus s2 squared divided by n2. Okay, so those will get you confidence intervals in those situations right there. Let me kind of take this one step further. So we have these two ideas right here. Okay, with the confidence intervals, again, what's going to take place if your confidence interval comes out to be a positive, that means that mu1 minus mu2 is greater than 0. Okay, if it's negative, that implies that mu1 minus mu2 is less than 0. And then if it's a negative positive, that implies that mu1 minus mu2 is question mark to 0. We are unable to determine a difference between. I don't know where I got my spelling skills today. I must be rusty. Okay, so that kind of goes along with the confidence intervals. All right, so I'll place that over here. See if I can get it all into one page here. Very close. Okay, and then the problems that deal with probabilities, you may not have that much experience, because I know the class period kind of got cut short there for some people. Let's obviously talk about that. So let's first talk about the confidence intervals. So a confidence interval, as far as probabilities are concerned, is p hat 1 minus p hat 2 minus e is less than p1 minus p2 is less than p hat 1 minus p hat 2 plus e. Okay, with the same results as down below. If it's positive, positive, then that middle part is greater than 0. Negative, negative, then that middle part is less than 0. And then if one's negative, one's positive, then it's a question mark to 0. Okay, how to get some of these things. The margin of error in this situation when it comes to probabilities is, again, a ZC, and it's going to be p hat 1 q hat 1 divided by n1 plus p hat 2 q hat 2 divided by n2 square rooted. There's that bit of it. And then the finer technicalities, what a p hat is an individual r. Let's go p hat 1. It's r1 divided by n1. And then q hat is 1 minus p hat. Okay, that will get you the confidence intervals right there. Okay, then last but not least is the hypothesis testing with probabilities. Okay, the hypothesis testing with probabilities, and this one, okay, you're going to be getting a z off of this, okay, not a t like we do over in the differences, but a z, and z is going to be equal to, let's start with the denominator, p bar q bar divided by n1 plus p bar q bar divided by n2 square rooted of p hat minus p bar. Let me just check that one. No, excuse me, p hat 1 minus p hat 2. All right. Here you need to know what a p bar is, and that's going to be r1 plus r2 divided by n1 plus n2, and then again, obviously, q bar is 1 minus p bar. And again, that will get you a z, and when you look that up for the p-value again, obviously look that up as a negative. Let's turn that into a different color. Okay, so those are the different types of problems and the different types of breakdowns for these things. You need to probably have these on a formula sheet somewhere. All right, let's get down to business. Let's go ahead and handle our business. Okay, so we first have the problem in which we are to do a hypothesis test of these shoes. All right, so again, the difference is going to be x1 minus x2. The average is going to be the sum of those differences divided by the number of numbers. All right, calculator speak, the difference is going to be x1 minus x2. So I am going to enter those into lists, and that is going to be list 1 minus list 2, and I'm going to take that list answer and store it as list 3, and that's going to be my differences. That's how I start this process. All right, so again, x1 is going to be list 1, x2 is going to be list 2, then I'm going to create this difference, which is going to be list 3. So let's go ahead and start with that. Okay, so I'll thumb through real quick just to make sure you didn't make a mistake. Okay, it's halfway decent. So I go to my main calculator and I go list 1 minus list 2. So these are the differences. And so what I do is I take that list answer and store it as list 3. Okay, those are now our differences. Okay, the next thing I need to get is the average of those differences, this D bar right here, the average. And so I need to add them up. So I need to take the sum of list 3 and then take that answer and divide it by the number of numbers, the n in this situation, which is 9. I'm going to take that answer and I'm going to store it as the letter A for average. So when I'm done with this, my D bar is going to be the letter A in my calculator. Okay, I need to find the average of what I just created. So I need to sum that, so catalog T up couple. List 3, so I'm taking the average of list 3, my difference is, divide by the number of numbers, which is 9, and then store that as the letter A. Okay, now we're technically now on to the very first question, which is the standard deviation. Okay, S or SD, however you want to report it, it's all good. And so this is going to be the sum, open, open, D minus D bar, closed squared closed, divided by n minus 1, square root. So I begin with the inside numerator, so that's going to be the sum, open, open, of D, which is list 3, minus D bar, which is the letter A, closed squared closed. That will give me my numerator. I need to take that answer and I need to divide by the denominator, which is n minus 1, which in this case would be the number 8 in this particular case. All right, so that gets me the entire fraction. I need to now square root that. Okay, that'll square root. This is our answer itself. And so I am going to take that answer and I'm going to store it as the letter S. So when all said and done, my standard deviation will be the letter S in my calculator. All right, here we go. So I sum D minus D bar, closed squared closed, divide by n minus 1, square root that, and that is going to be that, so I store that as the letter S. Make sure you actually write it down, though, because that's what the question was asking. Okay, so we're done with storing things into our calculator. I think from here on out, it's just doing the problems themselves. All right, this next one is the sample test statistic, T, which is going to be D bar divided by S divided by the root of N. If you have the ability to use the fraction option in your calculator, please do that. If you don't, like you're kind of like me, no big deal. We can just walk it through. Just make sure you keep the denominator in its own unique parentheses. All right, so this is going to be D bar, which is the letter A, it's our average, divided by, and here's where I have to put my own parentheses, S, which is S, divided by the square root of N, which in this case is the number 9, so the square root of 9. And that will be our letter T. There's no need to save that into your calculator or anything. Okay, degree of freedom, that one's easy. That's n minus 1, so in this case, that's straight up 8. Here we need to make a p-value and a sketch. So our p-value in this situation, so just a little bit more room. All right, so the p-value in this situation is going to be built upon a t, which is 2.1122. And a degree of freedom of 8. So I look that up on my t-table. .1122 degree of freedom of 8. All right, so on the degree of freedom of 8, I'm looking up 2.1122, which falls right in between 1.860 and 2.306. I'm assuming that this is a one-tail. I'll have to take a look at that, but I'm assuming that's a one-tail, which would put us between 0.5 and 0.025. Okay, yes. The way that I know that it's a one-tail is I look at the next problem and I see that it is a one-tail with an alpha of 5%. It's more specifically a right tail. Okay, so degree of freedom of 8, it falls in between 1.860 and 2.306. Looking up, that was in between 0.50 and 0.25. Okay, so this is a right tail. Looking at that next problem, this is a right tail with an alpha of 5%. Okay, so we put our p-value on there. Our p-value is the same with one, so we default to the other. The other is smaller, so we go with the smaller. Okay, so it's smaller, it falls into that rejection zone. Okay, now the next part of this question, we have some breaking down to do. Okay, first, what does our p-value to alpha say? Our p-value is less than our alpha. P-value is less than our alpha, so that means we reject H naught and accept H1. Okay, H1 is what we're in essence taking, H1. H1 in the problem is defined as mu of D is greater than 0. That's what H1 is saying. Mu of D is the same thing as saying x1 minus x2. And so we slide it over, and so we see that x1 is greater than x2. Cool. So this is what we have to say. So x1 is greater than x2. x1 being the punt distance of the new shoe, x2 being the regular shoe. So Again, make sure you're using the mathematical words. Don't say is more than, is bigger than, is longer than, is anything like that. So is greater than is that middle symbol. So is greater than. Okay. If things would have turned out differently, um, this is what this would look like. So again, I'm looking up into the problem to know what that means. So it's mentioned right there. So just look back up in the problem. And then here we go. So we're unable to prove a difference between the punt distances of the new shoe versus the regular shoe. I don't have to say the word average because we're not talking about mu's, we're talking about X1 and X2. In the other situations, yes, you would have to include the word average or probability, whatever the case may be. All right, here we go. These are the confidence intervals and the margin of errors. So here, the margin of error is, this has sigmas, so this is going to be ZC of sigma 1 squared divided by N1 plus sigma 2 squared divided by N2. Okay, and here the ZC is based upon a confidence of 95%. Again, we take a look at the Z table at that little box at the bottom to get that ZC. So if we look at the Z table, there's this little box on the bottom of the positive side. We see that the ZC of a confidence of 95% is 1.96. Okay, so we have enough stuff to plug and chug in this situation. Very specifically, what I type in and how I accomplish this is I take sigma 1 squared divided by N1 plus sigma 2 squared divided by N2. Okay. I square root that answer. And then I take that answer and I multiply by the ZC. Okay, so sigma 1 squared divided by N1 plus sigma 2 squared divided by N2. I square root that, and then I multiply by ZC. Okay, Now I go ahead and create my confidence interval, which is x bar 1 minus x bar 2 minus e is less than mu1 minus mu2 is less than x bar 1 minus x bar 2 plus e. That middle part stays the same, and I just get the answers to the two sides. So x bar 1 minus x bar 2 minus e and then x bar 1 minus x bar 2 x bar 1 minus x bar 2 plus e. Okay, I notice that the answers here are positive, 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 positive. And so when they're positive, positive, that implies that mu1 minus mu2 is greater than 0, thus mu1 is greater than mu2. So the average of 1 is greater than the average of 2. And so again, where I look to describe my words is the X bar, profit percentage of stock. So the average of 1 is greater than it's defined as stock B. So the average of 1 is greater than the average of 2. It's just like the problem that we got done doing. So again, if this were a negative positive, then the words that we would say is we are unable to prove a difference between the average profit percentage of stock A versus stock B. Okay, this next one is a very, very similar problem. However, because this has S's, our formula changes a little bit. So don't look at the ZC to get your T again. So this is a TC. So what we need for this is we need to know the confidence. The confidence here happens to be 95%. We also need to know a degree of freedom, which is n minus 1. Now, again, as I mentioned before, what you do is you choose the smaller of the two n's, and you take the degree of freedom from it. So the degree of freedom in this particular case happens to be 15. And then you look this up on the T table. So here we had a degree of freedom of 15 and a confidence of 95%. So again, one more time, how to use this, you kind of look at this box right here. You look down for the degree of freedom of 15, and you look across for a confidence of 95%, which is that one. So we see that those two things intersect at 2.131. That is our TC, 2.131. Okay, now we are ready to go. Again, we pretty much do the exact same calculator process as you see up above in green. Pretty much the same thing. So S1 squared divided by N1 plus S2 squared divided by N2. Square root that. And then multiply, in this case, by TC. Okay, here we go, confidence interval time. It's the exact same formula as above. So here we go. So we take x bar 1 minus x bar 2 minus e. And then x bar 1 minus x bar 2 plus e. Okay, so what I notice about this answer is this is a negative positive. So this is the question mark, and we're unable to prove the difference between. So this means mu1 minus mu2 is question mark to 0. I don't know if it's bigger than 0. I don't know if it's less than 0. So mu1 is question mark mu2. So the words that we say in here is we are unable to prove a difference between all right, and so here we do have to describe these as the average. We look at the X bar for our description, so daily sales. Okay, of 1 versus 2, brand A versus brand B. And so again, make sure, because these are sigmas, you do have the word average in there, and we are unable to prove a difference between. Okay, then we roll on to the probability problems. This first one is a confidence interval. All right, so the first thing that we need to get out of this is the p hats and the q hats. So for instance, p hat 1 again is r1 divided by n1, and then q hat is 1 minus p hat. So let's go ahead and get that for the 1s and the 2s here. So r1 divided by n1 then 1 minus that. And then we do this for 2. And 1 minus that. Okay, then we need to find the margin of error for this. And so again, this is going to be ZC of P hat 1, Q hat 1 divided by N1 plus P hat 2, Q hat 2 divided by N2. This is very straightforward. I'll just write it in green once on how to get this. So literally what I do is I go P hat 1 times Q hat 1 divided by N1 plus P hat 2 times Q hat 2 divided by N2. Okay, that gets you the inside. Square root that answer, because it's inside of a square root, and then take that answer and multiply by ZC, which reminds me I have to look up a ZC. So the ZC, again, is built upon, this one has a confidence of 90%. So again, take a look at the Z table for that. that little box. This one has a confidence of 90%, so the ZC is going to be 1.645. Okay, so this, we're ready to plug and chug. So here we go. P hat 1 times Q hat 1 divided by N1 plus P hat 2 times Q hat 2 divided by N2. Just make sure you didn't miss a decimal or something like that. All right. I square root that and multiply by ZC. And that is our margin of error. Our confidence interval in this situation is P hat 1 minus P hat 2 minus E is less than P1 minus P2 is less than P hat 1 minus P hat 2 plus E. Okay, so let's see what my P hats are. So here we go. P hat 1 minus P hat 2 minus E. So that is E, so that is 0026. Positive though, it's positive 0026. P hat 1 minus P hat 2 plus E. Okay, what I notice about these is this is a positive and this is a positive. So that means that that middle P1 minus P2 is greater than 0, thus P1 is greater than P2. All right, so what does that say about comparison in context? So the probability of 1 is greater than the probability of 2. Okay, so I use the R as the descriptor. So meeting target growth. Okay, so the probability of being of 1 is greater than 2. 1 is what? Population A, which is Kendra. So the probability of 1 is greater than the probability of 2. And who is 2? Lisa. Okay, again, if it were the other way around, that were a negative positive, then again, this would be P1 minus P2 is question mark 0, so P1 is question mark P2. Okay, and then we are unable to prove a difference between because this does involve probabilities, we have to describe it. So we're unable to prove the difference between the probability mean target of Kendra versus Lisa. Okay, the last type of problem is the the hypothesis test. So all right, so the first thing that they want us to figure out in this problem is, excuse me, p hats and q hats. Again, p hat 1, for instance, is r1 divided by n1, and what a q hat is 1 minus a p hat. Okay, so we have those out of the way. All right, since we are not given proportions, we must develop a p bar, q bar for our z, write the formulas for p bar and q bar for this calculation. All right, so, okay, so p bar is r1 plus r2 divided by n1 plus n2. If you have fraction capabilities, that's awesome. If not, what you have to do is use parentheses. That's how I have to type it in my calculator. Okay, now knowing this is a right tail for the write the formula for the z score for this given information. Okay, so z is p bar q bar divided by n1 plus p bar q bar divided by n2 square rooted, all underneath p hat 1 minus p hat 2. Okay, how I do this, again, it'd probably be a little bit easier if you had your fraction capabilities on your calculators like you guys have. I don't have that. So here we go. So I begin with the denominator. It's just a bunch of typing. It's p bar times q bar divided by n1 plus p bar times q bar divided by n2. Okay, that gets me the inside portion of the denominator. I obviously have to square root that answer. So this is my denominator. So thusly, I have to take the numerator. I have to make sure it's in its own parentheses. So I have to take p hat 1 minus p hat 2 divided by that answer. It's just kind of a bunch of typing. That's all it is. All right, so that first one, here we go. So we go p bar times q bar divided by n1 is 257. Okay, P bar times Q bar divided by N1 plus P bar times Q bar divided by N2. Okay, so that's the inside, so I square root that. That's the denominator, so I have to take the numerator, which is P hat 1 minus Q hat 1 divided by that bottom. This is a Z, so I round to 2. Okay, so this is a right tail with a level of significance of 5%. All right, so let's first find the p-value. So the p-value is built upon a Z of negative 2.17. I would look it up as a negative anyways. Wait a minute, that doesn't make any sense. All right, yeah, same idea. I'm sorry. I think I miswrote this question. It's all the same stuff, but this is going to be a left tail. I apologize. This is a left tail. Okay, it doesn't really matter much. It doesn't really change many things. But this is technically going to be a left tail. Sorry about that. I'll hopefully have that changed by the time you actually see the worksheet itself. Okay, so here we go. I still look up the p-value. Always look it up as a negative anyways. This is 2.17, so again, make sure you look it up on the z-table. So negative 2.17 is this 0.150. Okay, so left tail. Okay, so a p-value of 0.1 is way smaller. 0.150. So make p-value to a level significance comparison and decide whether you would imply that we reject H not accept H1 or do not reject H not. Okay, so here we go. So the p-value is less than my alpha, so thus we reject H naught and accept H1. Okay. So knowing that H naught is PD is equal to 0 and PD is greater than 0, what does this hypothesis tell us about P1 and P2 mathematically? All right, so we accepted H1. So H1 is this. So we're taking PD is greater than 0. All right, so PD, similar to mu of D. All right, so mu of D was x1 minus x2. Okay, P of D is P1 minus P2. That's what it is. Okay, so this says P1 minus P2 is greater than 0, because P1 is greater than P2. or excuse me, I'm sorry, because this is the left tail. Those creepers. It's going to be is less than. Again, I'll have this all fixed by the time you see this paper. Yeah, that's what that means. So the probability of 1 is less than the probability of 2. Take a look at the R for my descriptor. Owns more than one dog. I'll call that multiple dog ownership. Okay, the probability of 1, which is in 2000. Probability of 1 is less than the probability in 2010. Again, if it were the other way around and it was PD is equal to 0, and then that we would say we are unable to prove a difference between the probability of multiple dog ownership of 2000 versus 2010.